so many attendees from all over the world joining us for this webinar. My name is Elpira Luzolo, business developer for the Southern African region for Odyssey Energy Solutions. I will be your host for this webinar, and I'm so excited to have the opportunity to be part of this exercise today. I won't be alone. I will be joined by two of my colleagues that I will be introducing to you shortly. I see a few people are still joining us. Very excited to see that. The numbers keep climbing up. Again, pleased to see that. We're going to give it another minute before we kick off with the actual webinar. So please feel free to settle in and to compile your questions. I invite you to compile as many questions as possible. As we go, as you have them, there's no such thing as stupid question. Please share them with us. We'll be more than happy to get back to you with an answer. We should be able to start in a moment from now. I see people are still joining. I'm very excited to see that. On behalf of Odyssey, we'd like to thank you for availing yourself and making time today for joining this webinar. I believe it's going to be informative and it's going to add a lot of value with some of your operations and applications that's probably you've been battling with. As a matter of fact, very soon we'll be able to launch a poll to get a bit more information in terms of your experience with some of the genset integration solutions that you've been using to date. We'd be keen to hear about some of the pain points that you've been experiencing, and of course, some feedback from what you enjoy the most with your current solutions. I see that we've reached quorum. I'm excited to be able to kick off in a minute, but as you can see, there is a poll that's already accessible to all attendees. Please feel free to give us the relevant and required information, as this would be much appreciated. All right, so I see that I've been joined by two of my colleagues, namely Patrick Cen, Vice President of RMC Solutions, based in Germany, with a wealth of experience on battery storage, system integration, and remote and control. Also joined by another colleague of mine called Piyush Jain. Very pleased to have you here. Engineer for RMC Solutions, previously with Rolls-Royce Power Systems, also with a wealth of experience when it comes to power systems and power control and systems integration and equipment control. Patrick, welcome and thanks for being here with us. Piyush, welcome and thanks for being here with us.
Yeah.
Thank you. I'd like to start by introducing Odyssey Energy Solutions to our attendees. I believe that some of us are already familiar with the company, the name, what we do, what our values are, what we stand for, and what we represent. But I also recognize the fact that some of our attendees are not necessarily familiar with us as a company, our mission, and what we do. Odyssey is basically a global company in end-to-end tech platform that converges all the major stakeholders of the distributed renewable energy industry across the world. And by major stakeholders, I'm specifically referring to suppliers, project developers or EPCs, and financiers. I believe that some of our attendees may be one or the other. And if I look at the geographical representation of our attendees, it's a truly reflection of what we really are as a company. Our footprint goes across the world, very strong in the Northern American continents, the South, East, West, Southern Africa, Europe, and of course, Asia. And I can see that we have people from all over the world joining us today. We offer mainly 4 products or 4 services that are considered as business units within the company. We have a plan and forecast tool, which is nothing more than an online platform that allows you to generate a proposal based on the information that you input on the platform and populates and generate a proposal that's ready available to other stakeholders, i.e. financiers, for instance. It's widely used and we're getting a lot of praise for the fact that it's user-friendly, very accessible, and most importantly, free of charge. Our second business unit or service that we offer is the finance. We have a lot of funding available for your project. We invite you to engage with us. We have over 1.3 billion US dollars of financing available, over 40 programs, and that's a subject of discussion that we'd like to have with you on another platform. We have the procure business units or the procure service that we offer. We've realized that a lot of developers or EPCs across the world end up paying more than they should, just because they don't have the capacity to engage directly with manufacturers, or in some cases because they don't necessarily have the financial muscle to engage directly with OEMs or manufacturers. We decided to put together a solution that facilitates access to warehouse or manufacturing pricing for most of our developers. And that's something that we offer really well on the procure side. And then last but not least, and most importantly, what we're here for today is the operate business units, which is nothing more than a platform that offers remote monitoring and control tools that we have available. As a matter of fact, there's one in particular that will be the subject of discussion today on a very important and a very hot topic across the world, and especially in the geographies where power outages are getting more and more frequent and more acceptable when they shouldn't be. We understand that on the Operate platform, there are certain products or certain controllers and sensors that one could use. I'd like to invite Patrick to tell us a little bit more about it, to give us a high-level overview on some of the main products of the Operate platform, and from there, advise on what's really would be the most relevant one for the sake of today's discussion.
Yeah, thanks, Elpira, and good to be here. Well, basically, there's a number of controllers that we have. The Fern Flex controller is about a hand-sized single-board computer, which is the core of what we'll be talking about today, which is the Fern Hybrid. The Fern Hybrid is a finished box, a solution which allows various components to be connected to it, including generators, inverters, energy meters, and other sensors. So that's the core of what we're talking about today. But of course, that is there in order to have access to Fern View, which is the portal which all of our customers can reach from anywhere in the world just using a normal browser. With that, you can see what your portfolio of generation equipment is doing. You can also drill straight into a single system, change settings and so on. So there's a lot of possibilities that we can use. We also have smaller data gathering devices, which are used in other circumstances, but not so much for the one we're talking about today.
Thank you, Patrick. That sounds very exciting. It's clearly a whole range of products and solutions available to the market, and I'm sure that leaves us with a lot of questions. While I'm excited to learn more about it and to see really what Odyssey has been up to, I'd like to start with the fundamentals. I'd like to understand. I mean, we're talking about a photovoltaic genset integration kit. I'm still not quite clear on what really this means. Can you help us understand what a PV genset integration kit really is?
Yeah, so I have to say here, of course, that there's so many different types of generator integrations with rooftop PV on their own, with batteries, that when I'm talking about this, it of course depends on the type of system that you have or that will be built. So not everything I says here applies to every system, of course. I've got to say that. What you see in the picture there is a basis version of Fern Hybrid, which consists basically of the Fern Flex controller, the device on the lower right-hand side, which collects data. It needs to remain powered, so we have an uninterrupted power supply in there. We monitor then that the power is available and the battery is okay. And then we also have an Ethernet switch, and that data then goes to Fern View via a modem. Near the top, you can see a kind of a big gap. Well, usually that would be full with various digital analog sensor devices, maybe a energy meter. But of course, there are systems that don't need one energy meter. They might need 8 energy meters, and that's possible too. It just wouldn't sit inside this box. So really what we're doing is we're communicating between the generator, the grid status, the loads, and the PV in order to reduce as best as possible the amount of runtime the diesel generator needs to have.
This is very interesting. Just like Odyssey converges stakeholders of the distributed renewable energy across the world, understanding or my parallelism from this device is that it converges also the PV genset on the one side to the PV solar system on the other side to facilitate the interaction between the two. Is my understanding correct, Piyush?
Yes, yeah, you are correct. So the basic thing is like whenever we want to do anything, just monitoring is the first step to reach out to any conclusion. So yeah, all of these components can get the data from all of the devices and integrate all of them in one dashboard.
That is very exciting, very exciting. I mean, I know for a fact that it's a hot topic of discussion, especially in the African context. So I'm excited to learn more about it. But I understand that there are many systems, many inverters out there. I mean, you get different brands, you get different types. Is this solution, the Fern hybrid, a solution that can be really claimed to be compatible with any brands that's out there? You know, I mean, I'm very familiar with a few brands that are popular in Nigeria for some of the people who are joining us from Nigeria. I know some brands that are specifically popular in South Africa. And the requirement would vary, obviously, from one country to another. Is it fair to say, Piyush, that this solution can adapt pretty much any inverter out there?
Yes. So here I would say that the sky is the limit. So whatever equipment is there out in the market, we are able to communicate with those inverters and control them until unless they have some certain technical specifications or communication capabilities. So that is possible so far. So from this webinar, there is an option for diesel genset, and I see that Deep Sea, ComApp, and Cummins are the common options. But we also support other brands as well, like Basler or Dye as well. So yeah, feel free to suggest your own opinion or equipment if you have and different components as well.
That's very impressive. Is there something you'd like to add to that, Patrick?
Well, what Piyush said is true. We have this compatibility here. This is actually not all of the compatibilities that we have, and we are willing to talk to our customers about extending that all the time. There is a, there's a possibility that we cannot connect to something. But if, for example, you've got a very old generator, which is, say, an analog and manual generator, still not a problem, because we would put current clamps on the generator and we could monitor whether the generator is on, how much energy it's producing, and so on. Additionally, we could take that legacy generator and put a level meter for the diesel tank, so we can see what's happening there. So yeah, I would say that what Piyush said is true. We can deal with almost anything. So yeah.
I'm sure this is a product that's a lot of people, even our attendees, are really starting to discover and get familiar with. And I'm just curious to know, is this a new product that's coming into the market? Is this a product that's proven itself over the years in the market? Are there some business cases, some strong case studies over time, from this product? Has it been implemented in a variety of projects, in a variety of environments, environmental conditions? Or I'm very interested to understand that. Is there something you can tell us about it, Piyush?
Yeah. So far, from my experience with Odyssey, this system is already in running mode, and we have deployed almost more than 2,000 systems, and out of which, like, most of them are pretty online, and they are working fine within the system. And they vary within the range. Like, it is not only specific to the diesel genset business, but it is also applied for, let's say, agricultural products. You can use it in bottling plants, or in any kind of like environment, to monitor not only the specifics of the generator and the grid parameters, but you can do any other stuff as well. And to the point of your case studies, yes, there are case studies that have been done on sites, like how much we can save, or how much we can monitor with this controller at one site, or what we can do differently. Yeah. So yeah, Patrick, if you have anything else, yeah, you can add to for this.
Yeah. Oh, yeah, sure. So, I mean, our variety of experience, we've been using these controllers now for over 5 years. They have been implemented in a number of different sectors. There's some listed here on this page. For example, we have a number of telecom customers in Europe, in the UK. We have hundreds of mini grids in West Africa, in countries like Nigeria and Senegal, and in Ghana. We are also well represented in East Africa. In fact, yeah, I think we have systems in about 25 or 30 countries in Africa, and another 10 in other countries around the world. So yes, we are diverse and we are global. Yeah, of course, each time you set up a new system, it could be for several hundred quite small identical systems for a certain customer, in which case we would work a plan out, or it could be for a single grid connected diesel generator support thing. So we are really quite flexible in what we can deal with.
This is quite impressive. I mean, numbers don't lie. And understand there are over 2,000 of these units that are out there and operating as we speak. And I understand that we have some of these units really running in over 24 countries, which is something to be quite proud of, I'm sure, from an Odyssey perspective. But do we know about some failures that we've seen over the years from the Fern hybrids or the Fern controllers that are out there on the field?
Yeah, we do. So it's this product that we use, the Fern Flex, is manufactured in Germany. It's a good quality product, but of course you get failures over the time. To be clear, that we do have, of those around 2,000 systems, we probably have about 2/3 of them are Fern Flex, and the rest of these very small devices that I have in my hand here called a Fern Lite. And of those Fern Flex systems, we've had a handful of failures over the years that we couldn't attribute to an external circumstance. Usually the external circumstance, we've had a few that have been flooded. We've had a couple that have been blown up by a lightning strike, or had some sort of other mistreatment, which is explicable. But an actual failure is extremely rare. I think 3 or 4 cases over the years. So yeah, they're a reliable piece of equipment.
I think my bottom line understanding here is that this product has proven itself to be successful, to perform very well, to be reliable on different regions. That's a very good takeaway from it. But surely there's got to be some benefits in a product like this, Patrick or Piyush. Surely there's got to be some, particular benefits that one could enjoy from acquiring or implementing a solution like this. Can you tell us about it, Patrick?
Yeah, I'll maybe talk about the more commercial side of things and let Piyush talk a little bit about the some of the technical advantages. From a commercial point of view, of course, the main aim that we're talking about here is reducing the diesel generator runtime, because in most countries, the energy coming from a diesel generator is the highest cost, followed by the grid energy, and then, of course, PV energy has now become the cheapest source of energy. That's a generalization for most countries. And it also gets more complicated whether you're using a battery system or not. But we can all probably agree that diesel generator runtime is the biggest problem. So what we do is we try to have an approach which optimizes that, i.e. reduces it. And in order to do that, of course, we have to know what is happening within the system and then issue commands to make sure that that can happen. That could be either making sure that the rooftop PV continues to operate when it's running with the generator and doesn't overload the generator or get underused. But it also could be to decide what the target state of charge should be at the time that the grid fails. So there could be another reason for that. There's other things that we can do as well, like energy arbitrage, making a decision of which time of day energy should be bought from the grid and at which times of day it shouldn't. That would normally mean that you would have a battery system involved as well. Otherwise, it's very difficult to achieve that. But yeah, there's some of the main aims and the main achievements that we could talk about. There's other financial advantages surrounding maintenance, but I think I'll pass it on to Piyush to continue on that. We could go on forever about the advantages, really, but yeah, hitting the main ones.
Yeah, that is really a nice part, that there are so many advantages for this system. So the main point I would like to raise here is reliability. So if you want a reliability in your system, that comes with some cost. And obviously, like, you need proper internet connectivity. And even though if you do not have the internet connectivity, our controller is capable of monitoring or controlling these devices on itself, and later on sending the notifications when there is a resumed connectivity or internet connectivity at site. So that is the main advantage here, is like we can communicate with number of brands, not only with the generator, but inverters and the battery management systems as well. And that is an added advantage, that our controller is flexible to communicate with all of these devices at the same time and take decision and communicate or notify the user so that they can take the action proactively. For example, in one of the system I've used, like, there was a generator and the PV system and the battery. So whenever the battery goes below 20% of the power SOC level, then the generator automatically kicks in and notify the user that the generator has been started. And that is a good point. That is a good use case for a smaller system. And at the same time, when there is enough PV, but we still need the generator, then we can also cap the PV production for the load situation. That, for example, if to run the generator at an optimum rate, so that it can be more efficient in the operation. There is another advantage, that the customer can get proactively the troubleshooting or the downtime, can reduce the downtime by estimating the estimated fuel availability in the generator. And when we say fuel availability, I would say that, for example, in a day or two, we are going to experience an outage. Now we have to keep our fuel level up for the diesel generator so that we can cope up with the power supply with a reliable rate. So this is our controller is or the Fern hybrid solution is capable of doing all of these steps. So this is I know this is a lot technical stuff, but it is really useful. If we do have some of the manuals and our online tutorials which can emphasize on more of these benefits as well.
Thank you for that. This is very informative, and I like the fact that you've been able to give us some commercial benefits on the one hand and some technical benefits on the other hand, especially because I'm aware that some of our attendees are joining from a technical perspective and others are joining from a from a more commercial or financial perspective. So it's good to cover both aspects. Thank you very much. Very informative. But I still have a few questions. I mean, talking about the commercial side or the financial benefits, it's still a solution that gets implemented into a project. It's still a component of a project. And we all aware that projects are linked to a budget in a way. Is it really cost effective to install a Fern hybrid genset integration kit?
Well, that depends. Okay, so if I want to take a sort of a very high level approach at this, if it's a really small system, like a few kilowatts, it's obviously difficult to get a financial advantage out of it that would cover the cost of installing a Fern hybrid. We have to accept that reality. But once the systems are larger, or if the loads are critical, then it's a good idea to have a Fern hybrid installed, because either it can save you a lot of money, or as Piyush mentioned, it can increase the reliability of the system. And they're possibly the two main aims that you would have. So yeah, if it's a normal sized generator system, if it's above 10 or 20 kilowatts, it's quite easy to get a financial gain. But if it's several hundred kilowatts, it's a lot easier. That's how we could generalize here. Yeah.
Is there something you'd like to add, Piyush?
Yeah, that's true. And there is one thing, like there are facilities like hospitals and telecom companies, they need like 24/7 support or I would say monitoring for their devices. So that is an added advantage for their systems. So I would say that it is just the payback for you for the reliability you pay for. So that is the thing.
Yeah. I mean, maybe one last point to make here is that there can be conflicting interests within a generator system. So it could be that, if you've got a battery storage and a generator and PV, that you're continuously making a compromise between what you want to achieve. So the generator shouldn't be running if the weather's going to be okay in the next day. Obviously, the PV will pick up the load and it can recharge the battery. So therefore, you're fine with having early in the morning a very low state of charge of your battery. But there's other occasions when you think, well, the weather's bad and I'm expecting a grid failure. So therefore, I need to keep the state of charge of the battery much higher. So it's possible using the Fern hybrid to adjust the way you want to achieve, your arbitrage according to the situation that you have on that, on that particular time or on that site. So it gets a bit complicated, but it's the idea is that you need to achieve certain goals in order to be cost effective.
Very good. Very good. But we're still talking about PV solar systems. And these systems come in different sizes and in different applications. You mentioned earlier that for the smaller systems, 0 to 5 to 10 kilowatts, the cost can be felt a little bit. But for the larger systems, 100 or 50 or 200 kilowatt, and I'm not sure at this point in time how big you can go or how big of a system can be integrated to a generator. Is there some sort of a limitation in terms of PV system size or generator size when it comes to integrating a Fern hybrid into a system?
Yeah, that is a good question, and I would like to answer that on this. That practically, from the Fern hybrid solution, there is no such limit, but there is a limitation based on the number of controllers you can monitor at a time. It is just a technical limitation from the manufacturer of the inverter or the genset controller itself. So you can do monitor like up to 30 generators at the same time, or you can have like 30 number of devices at the same time based on the technical specifications of the generators, or more. But more or less, there is not a cap based on the ratings, but there is a cap from the number of devices which you can connect to one system. And even though it is about one system, like if there are many devices, then we can also amend another controller which can handle other devices as well. So that is that being said, that there is no such limit defined for this system. Right, Patrick?
Yeah, that's correct. But I do need to note here that we do not do phase synchronization. So if there are a whole bank of multiple generators in a larger system, it's still necessary to have a generator synchronization controller, because our way of controlling is more like a SCADA. It's once per second and not in the millisecond area in order to assimilate phases. So that's maybe also something to consider. We would then, in that case, usually communicate with the generator controller system.
Yeah, true.
Patrick,
So
Piyush, thanks for the information. I'm excited to see that we're getting more and more questions coming from our attendees. I'd just like to reassure you that we'll have a chance to go through your questions at the end of the webinar. So keep them coming. Again, there's no such thing as a stupid question. Please keep them coming. From my side, I'm not done. I understand what a Fern hybrid is. I understand what a genset integration kit is. I understand the benefits, but I'm still not quite sure on how it works practically speaking. I understand that we're looking at the PV on the one side and the genset on the other side, and the Fern hybrid in the middle, but how does it really work in a practical scenario where we have solar generating a plant and grid being available, and now all of a sudden we have a power failure? What does it really do, and how does it create a certain sequence of events, if it even does anything like that? Can you tell us about it, Patrick, please?
Yeah, so I have to maybe explain here that there's, again, I said at the beginning, there's so many different scenarios that we can possibly have. And we're just going to go through a couple here just to give you an idea of what could be happening during a grid failure. And what
I think that's a great idea.
Yeah, so we're only going to take 2 examples, but there are probably about 50 that I could think of. So it really does depend on the generator controller, the inverter system, the battery system, and so on. So if you could, yeah, right here, you've got it pulled up. So here's a typical beginning scenario. We have the grid running, the generator's off, the PV is working on the rooftop, and the load is being provided with power. If you go on to the next slide, you get a grid failure, at which point you can see that, well, basically it turns off. Okay, so at which point you need to tell the generator to turn back on. And when the generator goes back on, then after that, the PV will re-engage. Now, there are different versions of this, as I mentioned, but if the PV does then re-engage, then you have to be careful that it doesn't backfeed into the generator. So you want as much power as possible from the PV, but you do not want to damage your generator by feeding it backwards into the generator system. So the load could be covered to a large percentage by PV. That reduces your fuel consumption, and you're fine. If we go on to the next slide, we're in another scenario. Again, this will depend on the control features of the battery PV system as well. But you also got a grid failure, at which point, of course, the battery can go ahead and take over and provide the load with power without any, possibly without any break. What, though, can happen is that the PV will shut off because the battery system is not aligned or synchronized with the grid. And then the battery will be providing power, and then at some point the PV can come back up and it will be operating then together with the battery and generator system. Now, ideally in this case, of course, you do not need your generator at all, because the battery PV system is big enough, and because you were aware or you thought that maybe a power failure was going to happen, so you've got enough state of charge in your battery. And you don't get a sudden power failure at 7 a.m. when you're expecting the sun to come up, but it hasn't done it yet. Then you might run into trouble. So you have to make a decision as to what's the priority. But yeah, this is just giving you an example of all of 8 of the different stages of 2 particular scenarios.
Very good. I think this makes it easier for me to understand and to relate to how it really works in a more practical scenario. But on any system, there's obviously operation and maintenance that one has to keep in the back of their mind. How does a Fern hybrid really assist as far as operation and maintenance is concerned on a system over time?
Piyush, would you like to take that for a start?
Yeah, sure. So the thing is, this Fern hybrid solution is kind of like low maintenance device. Just needs a reliable power supply and internet connection. And even though if you do not have the internet connection, then it can also work without that for some time, at least like on the back end. So what it does is like it logs the data, it monitors the data, and it can control the devices based on the logic written on that controller, and it is totally customizable. So that is the flexibility of this system, that anyone can customize this controller with their own logic. Or for example, if you want to start the generator at certain point or certain time in a day, then you can remotely do that without sending anyone to site already. The other thing is like there is no other maintenance cost other than the internet connectivity whatsoever at site, because most of the site we think are approachable via internet connection, or so that is all I can say. There is one more thing, that if we want to let's say that we want to change the system, like we want to, like tomorrow we are going to buy a new generator, and whether it is possible to retrofit it, yes, that is 100% possible with the easy fix and remotely. No one has to go to site, but just for the basic other than the basic installation, anything can be done remotely, and pretty much you can get the notification about the different alarms, and yeah.
Maybe I'd like to add here a little bit to that. What's really important is that, of course, you don't want to get any failure events with these systems that are running. So you can set threshold notification triggers, as we call them. That sounds it's a mouthful, but what really you're saying is, if this temperature on some sensor goes too high, or if this voltage somewhere else goes too low, send me an email or a Slack message, and then I'll at least be able to go into the entire system and have a look remotely what could be going on. Maybe then I could immediately change a parameter to avoid a failure event. So that's one part of it. And the other one is you can have, if you want, you can, if a failure happens, suddenly a failure happens, you can then go back and look at the data of what happened during that failure event. So it could be the fuel ran out, or it could be who knows what. But because the Fern hybrid has its own power supply, even if power fails on the site, it continues to monitor what happened before and after the failure event of the power supply. So then you can look in from a distance and say, oh dear, the system's failed. But before you travel to site, you can have a plan as to how to remedy that situation. That would save you possibly 2 trips to site and would make your customer happier because you would respond a lot quicker to the problem that has happened. So there's quite a number of advantages there in O&M.
Very good. We see that the lifespan of the product is in the region of 10 years. The warranty is 1 year. So we're looking at a ratio of 1 to 10. Whatever happens, on year 2 or year 3 or year 4, if for a reason or another there's a failure with the product, which might not mean that the product is necessarily defective. How does it get handled? I see that there is free support. Is the free support on a day-to-day basis? How does it work?
Well, actually, the free support really means that if you need some technical support from one of our engineers, we can engage with WhatsApp or some email conversations, or even with a live session. When it comes to the actual hardware failure, as I mentioned earlier, it's a very reliable piece of equipment. There is a 1-year warranty, but like maybe a good car manufacturer, if something goes wrong and it would seem that it's our problem, we have on a couple of occasions just replaced a device at our cost because we feel it should be reliable. But that is so rare, and not what has normally happened is the device has been damaged by some outside effect, at which point, of course, we can arrange a replacement of the component that is affected. So it's not a big issue.
I've certainly learned a lot throughout this little chat that we had today. And I hope that our attendees have learned just as much, if not more than me. I'd like to remind you all that we as Odyssey are here to support you in any way. I understand that the subject of today's discussion was the Fern hybrid or the genset integration solution that we have for you, but you may have some other needs on the procure finance side. We'll be more than happy to engage with you and assist the best we can. You may have questions or queries or concerns beyond this session. Please feel free to drop an email to solutions@odysseyenergysolutions.com. I understand that some of our attendees are joining us from South Africa. I'm personally based in South Africa. Please feel free to reach out to me. It will be my pleasure to engage with you and assist with some of your requirements. If there are any of you joining from Germany, which I can see, some of you are, Patrick is based in Germany. Always a pleasure from his side to assist also. And of course, we have Piyush, who's based in India. But of course, we're not limited only to those countries. As explained earlier, we're really a global company. At the moment, we're even more excited because we're moving more and more south of the African continent after marking our footprints in Nigeria and the rest of the Western African continent, and of course, in the Eastern African continent as well. We're here to support you. I can see that questions keep coming up. This is probably the most exciting times because we'll have a chance to answer some of your questions. I will stop sharing my screen now and start going through some of the most pertinent questions. I see we have an attendee by the name of Yakubu asking a very important question here. Good day, thank you for this wonderful session. My question is, does the Fern hybrid offer economy of scale?
Well, you contact us, definitely. We're willing to talk. I'm not quite sure which country you're in, but yeah, give us a call if we're talking about scaling, if we're talking about a large fleet of systems. We welcome that, of course. The advantage of scale is if you have multiple identical systems, it's way easier to set the process up. So, yeah. contact us, please.
Perfect. So the short answer is yes. But of course, this can be seen as a vague question. We'd like to understand more really the context applicable to your applications, and of course, offer a more tailored answer. We have another question from Pablo. And by the way, as I'm going through some of the questions that we're receiving from our attendees, please feel free to ask more questions if there are any. We have a question from Pablo. What is the warranty period of the Fern hybrid? I believe this question has been answered already, but you know, for sake of reference, perhaps Piyush, you may want to touch on that again.
Yeah, there is like the failure rate is very low for that, and the warranty period is 1 year for the hardware, and you can get the technical support anyhow, like if you want.
Thank you. So the short answer is the warranty period is 1 year on the Fern hybrid. Another question from another good attendee here joining us today, Oladipo. I have a challenge with respect to synchronizing. How can we synchronize grid, solar, and inverter together? Is there a specific equipment for this? I'm tempted to say yes, and that equipment is called the Fern hybrid, which we've covered for the past 45 minutes. But please, Patrick, these questions are more for you than for me.
Yeah, I think that would be nice to say yes, but I would like to say, as I mentioned a little earlier, we do not provide the synchronization process because we do not monitor at millisecond speed. But there are a number of inverters which can monitor the grid, and therefore they provide effectively an uninterrupted power supply. They follow the grid frequency, and at the moment that the grid fails, they jump straight in with the battery energy storage system. But it needs to be a then grid following system. So not all inverter systems can do that. It is critical. It's not changeable really, but so it's critical that you make sure that when you purchase a system that it has that capability if that's what you need. But it is technically possible. And with generators, it's a little more complicated because generators basically run their own tune, but it is also possible to make generators follow grid as well, but that's more complex.
Again, very pleased and very excited to see such an engaging audience. More questions are coming up. There's another question from our friend Tayu. How can this help mini-grid developers? How can the Fern hybrid help mini-grid developers? You may want to take this question, Piyush.
Yeah, so most of the mini grids are in remote location or maybe in the center of the community where no one so if you are a developer, you may put your mini grid somewhere in a city or somewhere in another locality where you cannot be present all the time. So this would really help in the remote monitoring of the mini grid parameters. Like there are certain KPIs, you can say energy output, energy generated, which has been done last week, or you can compare. And the basic thing is like you can also reduce the cap, or you can identify whether whatever you are generating, you are getting the money for it returns. So you can also identify like whether you are getting the money what you are producing energy. So that is the main aim. And another thing is like you can also calculate how much carbon offset you have made while doing the generation or production of your PV power. So how many trees you can save. So we do have our own calculation setups set as standard values, which can be monitored or configured as well.
Mm-hmm. Yeah, maybe I'd like to add, of course, that Odyssey comes from the world of mini grids. We have a huge breadth of experience in multiple countries, including programs from governments and the World Bank, verification of results-based financing, So there are quite a variety of advantages of using the Odyssey solution for mini-grid developers. Yeah. I just noticed the other question, Elpira, that I think came up. I'm not quite sure. Came up twice on my screen. The thing about cold chain infrastructure. This is a really interesting one because we do have some experience with that, and we have a couple of customers who use the Fern box or the Fern solution to not only monitor the rooftop solar, but also to monitor multiple cool houses. And of course, the opportunity there is to use the cool house temperature as a battery. So if you've got surplus PV, you can cool it down a little bit lower. And if you haven't, then you can let it go up to its up to the limit temperature. So there's quite a number of opportunities around cool houses. Yeah, if you want to know more about carbon credits and renewable energy verification, please contact us. It's a subject that we're very interested in. So I just wanted to mention that one.
Thank you. Thanks for that, Patrick. We have more questions coming from our attendees. Is it cost effective to install a Fern hybrid genset integration for a mini-grid developer?
I would say yes. So yeah, it is. So what I have mentioned in almost during the presentation is the reliability. And if you are a mini grid developer, the main thing you want is like you want the minute update of the site, what is going on at the site, and you want to generate daily reports, monthly reports. Maybe you need so that is fine that you may have one system with one inverter set and you have second inverter with that second inverter set. You want to collaborate this all the sites all together, then this is the right place to do that. So that is worth investing, I would say.
Very good, very good. We have another question. I believe this question was covered, but it doesn't hurt to answer it again. What happens in the case of a failure after the warranty period? Would you like to take this question, Patrick?
Yeah. So obviously, the question was really a little more complex than that, revolving around, do we offer a 10-year warranty? Well, there are a lot of factors that are outside of our control when it comes to this type of system. So we don't actually offer a 10-year warranty, but we have the capability of assisting our customers to look into what has happened and to suggest a solution. I mentioned earlier in the webinar that our failure rates are so low that it's almost negligible, and that, for example, there are possibilities that you can get failures that we don't have control over, like flooding. So it's a complicated one, but we are always there for our customers, and that's yeah. And we have a lot of experience. So, but no, we do not actually offer a 10-year warranty at the price point that we're offering our customers, bearing in mind that we are a lot more cost effective than many of our competitors.
Another question from our attendees. This is from Raphael, joining us from Ghana, where we've had a couple of projects, I believe, in the past. Can the Fern hybrid read data and control SMA Sunny Island inverters? Piyush.
Yes. Yes. So we can communicate with SMA Sunny Island inverters and Sunny Dry Power as well. So there are like list of inverters which we can support. So SMA has a good profile, good portfolio which we can support.
Mm-hmm. Yeah.
And we are also operational. There is another question, like if we are operational in Kenya, yes, we are. And we do have some installation as well and going on in Kenya as well. So, yeah.
So just to add to that, related to the question whether we are operational in Kenya, again, the answer is yes.
Yes.
Kenya is our hub for the Eastern African region. Nigeria is our hub for the Western African region. And South Africa is our hub for the Southern African region, where I'm based. So yes, the answer is yes, we are definitely operational in all these regions. We more region oriented as opposed to country oriented. That's why you'll generally hear Eastern, Southern, or Western Africa as opposed to Kenya, Nigeria, and South Africa. I believe there's another question from Raphael again. In the case of a grid-forming battery inverters, which is AC coupled with solar, PV, green, and gensets, can the Fern hybrid monitor and control the seamless power transfer from each source simultaneously in a prioritization sequence as the PV, battery, grid, gensets as backup?
That's a complicated one, Raphael. So good question. First of all, we have to break that down a little bit. So as I mentioned earlier, we do not do synchronization, and it could be that the inverter system is capable of doing synchronization. But if it's an AC coupled solar system, that would normally mean that at the point of grid failure, the AC fails and the AC coupled PV would immediately turn off at that moment in time. If you have a DC coupled system that is connected to the battery system on the other side, it could possibly continue to provide power to the battery system, and therefore it would continue. So it really does depend on the architecture of your system, whether you can do what you're talking about here. And we are a monitoring and control part of that system, so we don't actually set up the architecture. To answer the prioritization, yes, we can be involved in the prioritization, especially when the prioritization varies according to time of day or according to your target of what you're trying to achieve. So that's an important point. So sometimes it might make sense to take as much energy as possible to be prepared so that a battery is ready for a grid failure. And other times it's good to wait until the early morning with the lowest possible battery setting, because you know the sun's going to rise and then the battery will pick up in its state of charge. So that's an example of varying prioritizations according to what's happening.
I'm sorry to interject, Patrick. We'll take one last question.
Oh.
It's a yes or no question.
Yeah, it's time.
The Fern hybrid compatible with the Huawei battery inverters 200 kilowatt hours?
Yes.
All right, that's perfect. I'd like to thank everybody, especially our attendees, Patrick, Piyush, for making this webinar as informative as it was. I'd like to remind our attendees that we're here to engage with you. I'm pretty sure that there's going to be more questions post this webinar. Please drop us an email or give us a call from wherever you are based. We probably are based there as well. So we'd like to engage with you, learn more about you. We'll go through the poll results, and we'll have all the information that we need. So just a reminder, Odyssey is here to serve you, to assist you, to connect you with your counter stakeholders in the industry, depending on who you are, whether you're a financier or a manufacturer or a developer. Talk to us and we'll link you or connect you to whoever you'd like to be in touch with. Thank you once again. I see that our allocated time has run up. I'd like to invite you to stay in touch with us until the next time we have the opportunity to connect again. Call us, send us an email. We'll be more than happy to assist. Thank you.
Yep. Thank you. Thank you.
Thank you.
Bye-bye.
Bye-bye.